Yeah. Can start. This study is about actually literature review we did on work on using large language model for service-oriented computing. Hassan and Joshua helped with doing the search for the literature. There are several considerable number of work on using LLM for service-oriented computing tasks. However, we were not able to find a proper literature review on them, and also there was no really proper research agenda for using LLM for service-oriented computing. So because of that, we decided to conduct a survey as well as create a research agenda. We follow the standard literature review protocol. Identify research question, come up with the search query, finding papers, selecting them using inclusion-exclusion criteria, and so on. In the end, initially with the queries, we got 700 papers. From them, we identified 64 after all the filtering. Then we used those 64 to extract the data and answer the research question. To organize our finding, we use the extended SOA architecture, which is also the architecture used by the original service-oriented computing research agenda paper from Mike and Frank. So in the extended SOA architecture, there are 3 layers, and one focus on the service foundation, which is about the middleware that support the creating, deploying, and publishing the services. Then second one is about the composition. Third one is about the management, monitoring and management. And there's also another aspect which is about the development and deployment. We use this architecture because with this we can thoroughly cover the service-oriented computing field. Regarding service foundation, service foundation is about the middleware infrastructure in the traditional or classical SOA. Main middleware was the enterprise service bus. With the microservice architecture, it was replaced by API gateway, service mesh, and event bus. When we going to use LLM, part of the microservice architecture, which means we use LLM to implement some part of complete logic of the microservices. Then we need additional middleware. This is called LLM or generative AI gateway, which is come from the practitioner. It's also proposed by all of the main cloud providers. LLM AI gateway is bit similar to the API gateway, but it's different because the API gateway sits between client and services. LLM gateway is to regulate the access to the LLM API. So LLM are deployed, some of them are locally exposed as services. For example, using Ola kind of framework. Then there may be some other also external LLM API. Microservices and other systems should be able to share this API in order to make sure that this sharing is regulated and properly done. Need a middleware. This middleware called LLM gateway. There are several already some commercial and open source products. This one do all the rate controlling, rate limiting, load balancing, data protection, a lot of other normal API gateway capabilities. This is the new middleware we need for LLM-based microservice architectures. Compared with the existing middleware, we need another new middleware. Then regarding the literature, regarding service state of the art, there were only few work focused on the service foundation. The one work on service recommendation, we are trying to recommend the service for a specific task in the workflow. Then there was another work that tried to generate the optimization logic to select services based on the natural language expression of the optimization requirement. About the research challenges, about the research opportunity and challenges, here I'm trying to briefly present some idea we think which have potential. In the research paper we have more description of this with all justification. I'm here trying to briefly mention them. One of the potential issue is the LLM inference, which is when we serve the LLM model, resource management for them. Of course, there are a lot of work on resource management, but when we have the LLM workload, they have different characteristics. LLM model are different, even the request type are different, natural language, they are arbitrary, and so on. There are a lot of different characteristics compared with any other machine learning model. So there's a need for understanding the resource usage and the usage of this LLM workload. When we consider the LLM integrated microservice architecture, it may be possible existing microservice component like normal services, API gateway, as well as the LLM model, LLM gateway, everything deployed in maybe same Kubernetes environment. In that kind of environment, we call mixed workload. Again, there's opportunity for understanding as well as optimization resource usage and energy consumption for mixed workload. Another option or possibility is to consider the LLM gateway capability, though these capabilities are lot similar to the, at least in a high level, similar to the capability of API gateway. They are different because, for example, because LLM are non-deterministic. Let's say that we want to, when we microservice call LLM, then it's failed, then if the microservice want to retry, there is no guarantee that the response will be same. And also it cannot payload to any alternative LLM because even the two different LLM, even same LLM instance can produce different answers. Caching is very difficult. Caching is the semantic caching because it may be possible that the natural language expression they characterize so grammatically may be different, but they mean the same thing. So ideally the response should be same. So while they are bit similar to the API gateway cable, the implementation for the LLM based API can be different and can have its own research challenges. In fact, there are also a few work try to focus on the caching and so on. Another option will be we can use the LLM for implementing the service capability. So we use the LLM to do some business logic, for example, validating the request, access the database, and do the data transformation and so on. However, there is no direct study on how should we select what part of service should be implemented using LLM and what will be the pros and cons. There is no real empirical study or guideline or anything for that kind of work. So there is also a big opportunity. Same for the middleware. In the middleware level, traditionally we use a multi-agent system for service annotation, semantic annotation, publication, discovery, and so on. Probably now LLM can do same thing, maybe with different advantage or disadvantage, but there's no really study on trying to understand the advantage, disadvantage. Another one, potentially we can use. It's also very important, I think, especially when we use the middleware like Kubernetes, very complex. To help the developer or operational people to really diagnose the issues and configure correctly, can provide their assistance, chatbot, which is also, in fact, some open source code. Maybe there are a lot of research issues on that because there are a lot of research that use, for example, using manual to correctly configure database and so on. Maybe LLM can help with that kind of problem. Then there's let's say that we use LLM in the microservice architecture, especially in the service foundation part. Still we have common issue with LLM, which is the trustworthiness and security. LLM hallucinate a lot, and also they can have a bias in their decision. Then if the microservice use LLM, then the decision made by the LLM can be wrong or have a bias. And also when we use the LLM, when we integrate LLM into the microservice architecture with the LLM gateway, then it add more complexity and also add more vulnerability. For example, there's a increased number of threats, like for example prompt injection, where some attacker can intercept one microservice and infect the prompt so that the prompt instruction are override, then which lead to the misbehavior of the LLM and so on, can do a lot of harm, and also model threat, which mean for example extracting the weight of the model and so on. So there are a lot of threats, new threats introduced by this architecture. So there are potentially also opportunity for further investigation into the research. Regarding the service composition, there are a few work on generating executable service logic, including the process model, and also one work using multi-agent system for automatic service composition. One minute. Oh my God. Sorry, Oliver. Then I will speak. Then there was another study on mining, for example, source code logs are in natural language, so LLM can be used to mine them and identify, for example, dependency graph, which can help to, for example, generate policy and so on. Then research opportunity-wise, one is the composability analysis. Again, there was a lot of work on the SOA domain for this. However, LLM can probably help go beyond the semantic matchmaking, considering the more information like the, for example, policies, service usage history, user comment, like social aspect, and so on. Then another research opportunity, to use the already someone actually already have already used this, to use the autonomous agent to improve the adaptability and flexibility of the service QoS area service composition. Especially the LLM can use a lot of domain knowledge to, for example, very common when we execute the service, always there is failure. Then to understand the failure correctly and take the correct action, maybe it can utilize the domain knowledge. Here again, LLM can help. While the multi-agent can be used for service compression, but there's no really proper study on the scalability and robustness, especially multi-agent systems have a lot of many failures. Then also when we use agent, when we increase the number of agents, failures are also increased. So it's also important to study how scalable and robust multi-agent when we use for service compression. Again, similarly, when we use LLM in the service compression, again we have the security and trustworthiness issues. For example, if you can say fairness issue, let's say that we have an agent that selects the service. If the LLM has populated bias, then it's possible it can select the same service again based on some bias thing like popular service. Robustness also common, like due to hallucination or contamination, maybe can select wrong service or insecure service. Regarding the insecure, selecting insecure service, which is one of the common attack in the microservice architecture. With the LLM, we have prompt injection. We can actually trick the service, the agent that is responsible for selecting service to trick select the wrong service is insecure service. So there's a lot of vulnerability when we use the LLM within the service composition. In the paper, actually, I described this in detail. Unfortunately, I cannot explain now. Regarding service management, the current work, there are a few work mostly focused on understanding the logs data generated by services, and also there was one work interesting that not just analyze the data but also try to come up with correct reaction. For example, reconfigure the system. I have only limited time, so there are several opportunities. One is the impact in detail, understand the observability in the microservice powers, LLM powered microservice architectures. While there were a lot of work on self-management system, LLM can actually help to build more sophisticated self-management system due to certain properties like domain adaptability and so on. Due to time, I think I will speak. Then also, even if you use the LLM in this context, still we have security and trustworthiness issues. Easily can trick LLM to do misconfiguration and so on. The last part is about service design and deployment. in here again there are a lot of work, mostly focus on business process, a lot of different aspects of business process modeling. Few work on test generation from microservice, and also one work on chatbot that support developer to find the services. Again, in this context, while there are a lot of software engineering researchers focused on using LLM for software engineering, however, still there are a lot of opportunity for microservice or service-oriented community. For example, in the microservice architecture, we use a specific method like domain-driven design and so on. Probably we can use LLM to automate this process, and then also even if you consider maintenance of microservice architecture, it's have a very specific thing compared to a normal software system. We can use probably LLM to help automate or at least partially automate these kind of activities. Same related to artifact, because artifacts are also in the microservice context, there's a domain specific artifact. This artifact generate, there's not really work on, sorry.
Give the time indeed.
Okay, so fine. Okay, I will skip then. Yeah.
Just a few words.
Yeah. So we did this little review on existing work on the SOA using LLM. We also created the detailed research roadmap. If you check the paper, maybe the paper will be available in probably 1 month. Then you will find more information as well as justification for each of the issues.
Thank you.
We don't have time for questions, so we really have to wrap it up. Many of us have an appointment at the beach or somewhere else. So I realize I have a bit of Dutch Greek time management. I apologize for that. But at the same time, I want to respect, I guess, the presenters. The next